Welcome to another video. We are going to discuss CATIA V5 Surface Machining. So to get started and also to make this as an easy to follow video, I will start and include also the part design within this video. So for the case study part, I will go to part design, select the X and Y plane, and over here I will define a center rectangle. I will start from the origin, and let's say for the vertical we will put 100 millimeters, and for the horizontal dimension 250. Afterwards we have that sketch. We're gonna pad it on a distance of 50 millimeters. Now for the following part, I would like to make something like a pocket and also remove one of the side faces. We could also make use of shell for this case study. So if I will go at the top for shell, we're gonna have the default inside thickness. So this will be, let's say, the thickness of the wall. If I will choose to remove faces, to remove the top part and also the face that is, let's say, facing to the right of the part, we're gonna see that the pocket, in this case the shell, will create a pocket like this. So this is one approach. I usually prefer to use, let's say, traditional pocket, because afterwards if I would like to change the thickness of the walls, I can easily do that directly within a sketch. So I will select this shell and I will have it deactivated, and I will create a new sketch on the top side. So now you will see that the shell will have this icon over here. That means that it is no longer active, and we can go back to the previously defined pad, define a sketch over here, and I will create a new rectangle at the top. And for this new rectangle I will select the top edge of the sketch, the top edge of the part. I will have those to be coincident. Since I have this automatic dimension for those two values, I will delete those values, and using the constraint I will add the 10 millimeter distance, which will also give us that same okay. The only problem is that I added the constraint at the top, so it will be mirrored to the original part design using the shell. If you want to, we can have that change. So I will delete this coincidence. I will put the value to be 10 at the top, and I will put it to be 0 on the bottom side. And as we can see now, since the part was actually, when I entered the sketch, we see that the vertical and horizontal was changed. So I will leave 10 at the bottom and 0 at the top. So this is a little bit, let's say, misleading in CATIA. When we position the sketch, we can go directly with sketch, or we can go with position sketch, because in this case we saw that the sketch was rotated. So keep that in mind when you're also drawing sketches within CATIA. And I will cut this on a distance of 40. So as we can see, we are, let's say, with the geometry exactly just like before with the shell, but now we can, let's say, more easily change those values if the design intent will require us to do that. Now, since this will be surface machining, I will want to make this case study part to have a draft angle. Therefore, I will use the feature known as draft angle in CATIA, and I will add a draft of 10 degrees for the three surfaces in the middle. As we can see, the one that are selected with the, let's say, brown color. And now for the selection, if I will use the neutral element to be the interior part, so the surface over here in the middle, if I will click on preview, we're gonna see that this will be our drafted part. We're gonna see that that will be inclined like that. So this will be, let's say, not intended for machining, as we have this negative draft over here. So we are gonna change that along, and we're gonna see we have this arrow. So this will give us that drafting orientation. If I'm gonna click on preview, we're gonna see that the newly drafted part will look like this. Now if I will click OK, we're gonna see that the drafting angle is correctly defined, but since I use the bottom surface as a neutral plane, the thickness of the sides will no longer be 10. So I'm gonna change that by double clicking on draft 1. And over here for neutral element selection, I'm gonna have this surface removed, and I will choose the top surface. So this will now be colored in blue. And I will click OK, and now we're gonna see that we're gonna maintain that 10mm wall, and only afterwards we're gonna have that drafted angle. Okay, so to finish the design part for this case study surface machining, I'm also gonna add some edge fillets. So the radius, I will set it to 10. I will choose the two inner edges. If I'm gonna click on preview, we're gonna see how those will be filleted. And now I will choose an additional fillet for the bottom surface, where it will also, let's say, meet with the wall, with the walls of the part. I will go for edge fillet. Now I will choose a radius of 50, and since this is set to propagation, that means that if I will only select this edge, it will automatically propagate using the tangency option, and within the preview we're gonna have our final part like this. So this will be all drafted like that and rounded. So this is the case study that we are gonna machine. Now in CATIA V5 we can make use of multiple part bodies to easily define which is the intended part to be manufactured. So that will be, let's say, the design part, and what will be the stock. I will select the existing part body over here, right click properties, and I'm gonna change the name to be, let's say, design part. We see that has been changed. And now I will go to insert, and I will add a new body within the same part. It will be by default named body 2. I'm gonna right click properties, and I'm gonna call this to be stock. Now we see that this is the active part body because we see it is underlined. That means if I will define a new sketch, the sketch will be automatically positioned over here. So to define the stock, I will rotate to the bottom of the part. I will select the bottom surface. I will define a new sketch over here. And I'm gonna make use of projection in order to quickly capture the exact shape of our design part. So I'm just gonna select the surface. Afterwards, I'm gonna click on project 3D element. And we're gonna see that the projected face will have the sketch in yellow, and it will follow the exact shape of our prismatic part. And with this sketch that is positioned over here in stock, I'm gonna have this padded. So we know that our original part had 50mm, and I will just have the pad go on to the top direction in order to overlap the design part. Now, in order to better visualize the difference between the design part and the stock, I will select the stock part body, right click, go to properties, and within the graphic tab I will choose the color. So I will pick yellow, and I will also add transparency. You can add let's say any value over here. I will choose 143 for this case. I'm gonna save that by clicking on OK, and now we're gonna see we have those two overlapping parts. So we have the stock and we have the design part. Now for machining we can also define a point, and we can also add a point over here. So if I would like my reference to be at the top of the part, I can easily draw a line. I will choose 2 points on the diagonal of the part, and afterwards I can go with point. I will select the line, and we're gonna have the option for the middle point, and this will create a point over here. So if for some reason we would like to define let's say the reference to be at the top, not over here where we have it on the original design part, we can use that within the surface machining. If you want to change let's say that point visuals, we can select the point 1, and we're going to have over here at the top within the graphic properties various options. If for some reason you do not have the graphic enabled, graphic properties, you can right click on the empty ribbon and you can enable it. It will be the third option over here. And you can also change maybe the color. For example, I'm going to make this like that, brown. Since this is a simple part, we can also define that point much faster. I can just create a new point. I can define it using the coordinates, and we know that our part has 50 millimeters, and I can just position that point exactly there. So 0, 0, and on Z 50 millimeters. And point 1 and point 2 will be in exact the same location. Okay, so we have the part finished. We can go to the surface machining. I will also save this, because if you want, CATIA will ask us to save that part. So I'm going to save this. I'm going to call this surface machining part. And afterwards, I will go to start machining, and I will select surface machining. Now we have the part open over here. We're gonna see that as soon as we will enter surface machining workbench, our selected part will be added within the product list. We're gonna find it over here, part 1 with those 2 part bodies. We can also hide the stock. It will be much easier later on to select the faces that we wanna machine. And now the next step will be to define the part operation. So I will double click over here within the process, 3 feature. I will double click on part operation. And we're gonna see that we have a list. We're gonna start from the top. So for the machine, currently there is no machine selected. I'm gonna select on machine, and CATIA will analyze the part. And we'll see that this will be optimal for a 3x machining. We can also go for others, but since this is a simple part, I will just use the default 3-axis machine. We see the default reference matching axis for the part is exactly where it was for the part created. So we can click OK on that. If we want to define a different matching axis, for example, if you would like this to be on that point that we defined, because for this machine we see that the home point, so this will be the tool point change, where the machine will retract in order to do the tool change and afterwards proceed with the following operation. We can have that adjusted over here within the home point, but this depends on the final machine that you are gonna do the machining. So I will just leave it like this as an example at 100 millimeters. Now we see that the orientation of the axis is really important. We have the x-axis, the y-axis, and the z-axis. If I would like to select that point from the stock, I can expand the stock. We know that both point 1 and point 2 have the same value. So that will be 0, 0, and 50 on Z. I can select this reference machining axis, and I can select the point within the newly opened window. And afterwards, I can select any of those points. And we're going to see that the reference for the machine will be added to that defined point. And we're gonna see that the tool change will now be at 100 from that point. As soon as I clicked OK, we're gonna still have 100 millimeters, just as we specified over here. So we can have this again change, and we're gonna see that that will also change. So the home point is set to 50. I see that it's still over there where it was at with 100. So let's take a look at why that hasn't been updated. If I'm gonna select this again, hit OK, hit OK, and now that tool point change, for some reason it's still at the top for 100, even though the home point has been changed over here. Not sure exactly why that happened. I'm just gonna leave it to the default 100. Okay, let me mute that. So I muted the phone. Let's proceed. We also have the design part. So we're gonna have the design part over here. We see that we have no design part selected. I'm gonna select the part body over here. And for the stock, I will select the stock. Now, for the others, for the case study, we are not gonna use fixture elements, because this part could be fixed even without overlapping the part. So this is quite a simple geometry. And we're also not going to use any safety plane for this case study, but those can be also defined over here as additional elements. Since this will only have a simple roughening and spiral milling and ZLevel, we are not required to have those. I'm going to click on OK, and we can now proceed with the operations. So I will choose the manufacturing program within the window, and afterwards I will select the roughening. We're going to see the tool axis will appear over here, and we're going to have a window with various settings. What is important is to add the elements that are currently red. So red is mandatory to be added. In this case, we're going to see that part is with red. I will select by clicking on this part, and afterwards I can come over here and I will double click on the design part, and that will be added. So the whole design part has been added over here. For the rough stock, as we can see, this is not with red. So if for some reason we won't have this defined, CATIA in some cases will recreate that stock according to the design part, but it's always a best practice to have that defined as well. Now we have those parameters over here. So for the roughening operation, we have offset from part that will leave 1 millimeter for all the geometry over here as an offset, and we also have offset on check. As we can see over here, we can define a surface to be a check area. That will ensure that during the machining, the tool will never come close to that check surfaces. So in this case, we can define, for example, offset on part. I'm going to set it to 0.1 millimeters. And offset on check, I'm still going to set it, even though I will not use it, in order to explain what exactly would that do. If I will have this offset on check 3, and I will select as a check the bottom plane, that means that during the roughening, the tool will never come closer to this bottom surface than 0.3 millimeters. So in this case, I will have this removed, because since this is a simple geometry, we can have that easily added over there. Now I'm gonna go over here within the strategy short help, and we're gonna see we have the machine tolerance. Now this is also highly linked with the machine that will be used for this. I'm gonna leave it like this with 0.1 for now. And some other changes that we can do. At the axial, we're gonna have the maximum cut depth is currently set to 5 millimeters, so we're gonna see the tool, and this will be the maximum cut depth. I'm gonna change this to something like 2. Afterwards, for the bottom, we can have the check to automatically, let's say, see the horizontal area. For this part, since this is quite a simple geometry, we don't have any underlaying horizontal areas, only this one. This shouldn't do any change to this case study part. And afterwards, we only have to define the tool. So for the tool, it will be the third tab over here. We're gonna have the 2D drawing of the tool. We're gonna have the name. And for the roughening operation, I will uncheck the ball end tool. But if I'm also gonna uncheck the ball end tool, I will remove the radius over here. So double click on the radius, make it to be 0, and this will be the shape of our tool. And we also have the aspects regarding the approach speed, the machining, and the retract speed. Now, these also are highly, let's say, depending on the hardware equipment used to do machining. I'm gonna just uncheck the automatic compute, and I'm gonna set the approach to be, let's say, 1500. This will be the machining speed. So I'm gonna leave this to 1000 millimeters per minute. And this will be the retract speed, when the machine will go back to the tool change in order to retract from the working surface, let's say. And for the spindle speed, I will uncheck the automatic, and I will add 3000 turns per minute. Now, we can also define some aspects regarding the approach. We see that for this case study part, we can just go with the automatic one, since the geometry is quite simple. We don't need to define specific approach and retract strategies for the tool. And we can now process. So if I'm gonna go over here on toolpath, we're gonna see that machining. Now, for this case study, we're gonna see that the machining time will be 1 hour and 11 minutes, so that is quite a lot. We're gonna change those parameters. But now we have the possibility to visualize the simulation. So I'll go over here, video. This will create an animation that we can control from over here. We can increase the speed by moving this slider. And we're gonna see that after this roughening, our tool, our, let's say, part will look like this. This will be the milling tool. We have the possibility to also go to photo, but if you're gonna try that directly, you're gonna receive a warning that a new simulation window exists. So the main difference between video and photo is that within photo we can also click on the 3D model to see various nominal values. So I'm just gonna go now to photo, but for that I will need to redo the simulation and directly click on photo. And now we're gonna have a, let's say, interactive 3D model in front of us. That means we can zoom closer. If I'm gonna select on this bottom, we're gonna see that over here we're gonna have a normal deviation of 2 millimeters right on the bottom. But over here we're gonna have the normal deviation for this drafted angle will be 0.18. Over here we're gonna have 1 millimeter, and you can check that, let's say, the roughening operation on the part. I'm gonna go with OK. And now I will increase also the machine tolerance. So I'll go over here with 0.01. If I will redo the machining, we're gonna see that the machining time is still 1 hour and 11 minutes. Again, I will go on that photo, and we can see those. So there are, let's say, not big changes if we adjusted the machine tolerance in this case. But if you want to further increase how much material we're gonna have removed over here, we can do some additional changes, but mainly to the speed. So I will increase the machining over here to 2000 millimeters, but keep in mind that this is closely linked to the milling tool used. But this, for a simulation case study, I will just have this set to 2000, and also to the material that we are going to work with. So some other changes: the maximum depth cut, I will set it to 3. So slightly increase that. This will also reduce the machining time. And we're gonna see that the total time will now be 24 minutes. And if I'm gonna go over here again, this will be the result after the roughening. Now, since this has been computed, it's important to click on OK over here, not cancel, because this operation will also be stored within the manufacturing program. And this will be the first one. I'm going to click on OK. We're going to see that that is defined as computed. And now for the finishing operations, it's important that we select the last operation that will add it afterwards. So I will have the roughening operation selected. And I will define a ZLevel for this. Again, we can specify the part, but since this is a finishing operation, we can specify only the surface that we want to finish. So right click on that, select faces, and I will select the interior faces of this part. Afterwards, I will double click on the exterior. That will leave that selection area. Now, if you haven't selected all the surfaces and you want to see exactly what you selected, you can right click over here on part. You can go to analyze, and you're going to see all the surfaces over here. The first button will also allow you to visualize the selection. So the one with green is also selected over here and highlighted in blue, but we can also see them with blue directly within the viewport. If for some reason you don't have them all added, you can add additional faces by going over here, select faces. You can reselect those and again double click on the exterior to exit that window. Now for this operation, we're going to have the offset on part no longer set to 0.1. Since this is the finishing operation, I will set that to 0. I'm not going to make use of the check surface, so I can just leave that offset 0.3 because we are not going to have that defined. And some other changes that we can do for this, I'm going to leave the machine tolerance to 0.01. We can also define the maximum horizontal slope. So for each parameter within CATIA, you can click on this question mark and you're going to see a drawing that will indicate what exactly will be that value. So for the maximum slope, I will set this to 7. And we also have the distance between passes. So this is quite important because we see our tool over here with the ball end. And depending on the distance between passes, we're going to have those small areas with material that will still be added on the part. So for the finishing, we're going to go back to the tool and we're going to change the tool to have the ball end. I'm going to set this to have a diameter of 4. So go over here, diameter 4. And I will also type in R2. This is, let's say, better to have those organized. And now, as soon as I will press enter, this will define that as tool number 2. I will set it to have a ball end, and we see the diameter over here. We will set that to 4, and we're going to have the radius of 2. And this will be the other parameters of the tool. We see the length. So we can also change, if we want to, the approach and retract strategy. We see now it's set to circular ramping, but for the case study part we can just have it to go along the axis because this geometry is quite open, and I will choose this along tool axis, and we're gonna see this will be the approach, so up to 10 millimeters. We can have this lower maybe to 5, and for the retract, again along tool axis, again to 5. And this retract and approach, they will influence the speed. So we see over here the speed when we have the retract. I will make both to 2000 for this case study. And let's say for the machining, I will slightly increase the speed of machining. We can now go to toolpath visualization. We're going to see that the total time will be 8 minutes. This is because I highly increased that speed, since you are no longer doing the roughening. We can also visualize, but as you can see over here, if I will start the play, we will initially have the roughening. So this is the first operation that we previously have defined, and we see that, and only afterwards we're gonna have the second one. So the second one will also have a smaller tool, as you can see. This also has a ball end, and we can see exactly those tool paths and how our part will be manufactured. We can also increase the speed. So we're gonna see that over here we're gonna have those areas. We can also add the bottom face within the same ZLevel, or can come with an additional operation at the end. So if I will click OK and go back again, go on the camera, we're gonna see that after this operation we're still gonna have the nominal value. So we see now we have the nominal deviation 1.7 over here on all the bottom area, but we have some regions where we'll be closer. So over here, for example, 0.1, 0.0 in this case. And over here at the top, we're gonna see that we're gonna have 0.0. So this is also highly related to the machine operation tolerance. But keep in mind that this is an interactive view, so you can come along and click on various areas and see what are the values. Okay, I will leave this unchanged, and I will just add the bottom surface to another spiral milling operation. So I will select the Z level, and afterwards I will define a new spiral milling. And within the spiral milling I will add the bottom faces. So this will be the selection. As we can see, there are 6 surfaces that are colored in blue. Now I will leave the same tool for this. And we have over here the maximum distance between paths. I will have this lowered to 0.5. Keep in mind that we have that radius on the tool, so we see radius of 2, and this will be the distance between paths. So this is important if you don't want to have those leftover material. You're gonna see a total time for this operation will be 11 minutes. And I will go directly to the finished surface, and we're gonna see that on the bottom we will have 0, in some areas 0.01, but over here we still have 0.4 millimeters in some cases. So we're gonna have that high point that we still need to clear. So we can do another operation. I will select the last spiral milling. We can also change the values of the spiral milling and see how that will act, but I'm just going to define a new Z level, and we'll reselect the bottom area. And I'm going to change the distance between passes to be something slower. We also see this scallop height. So this will be that height of those areas. We can also adjust that either within the ZLevel or within the spiral milling. So for this case study, there are quite a lot of finishing operations, so usually won't use so many. But I wanted to present various changes that you can do within the machining options to see how that final surface will look. And we see those operations, and now we should have that finishing operation that should slightly adjust those slopes. We are still within the ZLevel, end of simulation. And if I will go again and go directly on the camera, over here we can measure those. So as you can see, we still have a small slope, but that is not that high as it was. So 0.03 will be that height. We can further adjust that with various machining parameters. But for this case study part, 0.03 millimeters for that is more than enough. Keep in mind that over here within CATIA, these are also visual, let's say, more pronounced in order to see them better. As we can see over here at the top, we have this geometry, but as you can see, this face has a vertex over there, one over there, and one over there, and this will be the resulting surface. So keep in mind that this is also, let's say, a remeshed area of that that surface, because in reality we see this will be the nominal deviation for this case study. Okay, so I hope you find this video useful. If so, I will leave another video similar to this one over here to the left, and also subscribe button to the right. So thanks for watching, see you in the next video.